The principles of estimating are about trying to predict, for the future, what something is going to cost. There are a number of different styles, approaches, and methodologies used for estimating. You are asked to develop a high-level cost estimate. A senior government official wants to invest in their local electorate prior to the upcoming election and asks how much will it cost to build a new railway station. Don't worry, I won't hold you to your answer. I just need a ballpark. Do you A. refuse to answer on the basis that the scope is undefined and it can't be estimated? B. make up a random number? C. make some assumptions about scope and undertake a high-level cost estimate? D. seek out the average cost of recently completed railway stations and add 50%. E. compare a number of similar projects and provide a range of potential costs. Answer: it depends. So, how do we create a cost estimate? There are a number of different methods. One to consider is the top-down approach, often referred to as analogous estimating. Top-down estimating involves looking at previously completed similar projects and making relevant adjustments. Another approach is the elemental approach, where a project is broken down into individual elements. For example, in a rail project, components such as the per metre cost of rail line and cost per platform can be combined to produce an estimate. Different rates for different units are used, and it is often described as a hybrid approach. The next approach is the first principles or bottom-up approach, which involves looking at the cost of each individual component in the project work breakdown structure. This is the most accurate method, but requires the greatest number of resources. Parametric estimating involves using statistically generated evidence to deliver an estimate. For example, for an ice cream seller on the beach, the amount of ice cream sold depends on how hot it is. Using this, a formula can be created based on temperature and corresponding sales. If an organisation was looking to roll out an ice cream delivery service across the city, they could then use this formula to generate an understanding of potential ice cream sales. This can be mapped over a period of time to establish a demand profile. How long is a piece of string? This is the principle behind high-level estimating. You don't always have a scope or enough detail about a project to produce an aggregate cost. So, how do we actually describe an estimate? And importantly, how do we communicate the level of certainty and detail that goes into our estimate? Industry has moved in the direction of using a class system, with systems such as the American Association of Cost Engineering's Cost Estimate Classification System. Class 5 is a ballpark estimate. This would typically be plus or minus around 80%, depending on the industry. As an example, if you were asked to build a brand new train station in Sydney, developing a ballpark cost might involve looking at the cost of all train stations in Sydney and dividing this by the total number of stations to produce an average. Class 4 is the next level of detail, or your feasibility. This is plus or minus around 50%. At this stage, you have determined that the train station will be above ground, have 2 lines in either direction, and include an overpass. We don't know how long the platforms are or the level of excavation required, but we should have some examples of key unit rates. Class 3 is when we have a concept design. This will be plus or minus around 25%. We now know details like the length of the platforms and have high-level designs and drawings. A Class 2 estimate has a detailed design. Depending on the industry, the level of accuracy will be around 10 to 15%. At this point, there is still some level of uncertainty in terms of risks and time frame. Class 1 estimates have tendered rates. However, even if a lump sum contract has been developed, this cannot be guaranteed. For example, you might discover large amounts of asbestos or changes in design work are required. This is typically around 5 to 10%. We can now see that as the level of accuracy and clarity around a project increases, the level of variance or unknown decreases. Another consideration with estimating is understanding contingency planning, which is a risk-based profile, and understanding the difference between a P50 and a P90 and the contingency planning arrangements around these. 2 approaches to contingency planning include a deterministic and probabilistic approach. The deterministic approach quantifies risk as a single outcome or value. On the other hand, the probabilistic approach determines the level of risk in a project by analysing potential outcomes and expresses the level of risk as a range. P-values, such as a P50 or a P90, are determined via probabilistic analysis and give a level of confidence to an estimate. Let's say you prepare an estimate for a project and you estimate $10. If you were to carry out this project 1,000 times, there will be a distributed curve around this. This could be a normal distribution. However, the reality is that projects often come in over budget, skewing the results. For a P50, we can say that we are 50% confident that the final cost, once the project is delivered, will not exceed the estimated cost of $10. Alternatively, if we were to use a P90, we could say that we are 90% confident that the final cost will not exceed the estimate. Determining the desired level of confidence for an estimate can be done in a variety of ways. This is usually an organisational decision. Approaches to contingency management encompass a separate set of theory. A key concept is that contingency management cannot be done effectively without a good understanding of estimating principles and protocols, and strong risk management. Accurate, reliable cost estimates are essential for project success. One challenge in estimating is to ensure that cost estimates are not overly optimistic, resulting in significant cost overruns at project completion. It is crucial to adopt an appropriate estimating technique, account for factors such as risk and contingency, and communicate to decision makers the level of accuracy and detail that formed a cost estimate.